Hey, you're a scientist. We're picking back up where we left off. Yes, I know my voice sounds bad, and that's from allergies and laryngitis, so just bear with me. So I want to make sure that you are able to get your full review, so just grin and bear it, just like me. So we already talked about physical weathering, and our next thing to talk about is chemical weathering. But first, a practice question. Cracks in rocks widen as water in them freezes and thaws. How does this affect the surface of the earth? Well, this water freezing and thawing is going to be referring to ice wedging. So we know that as rocks go through this process of ice wedging, that it's referring to physical weathering. So your answer here is it exposes rocks to increased rates of erosion and weathering. So by the water freezing and thawing, that means that it's going to break down the rock quicker. So chemical weathering next. Chemical weathering is going to be done by chemical reactions that occur in order to break down rocks. So in science class, we looked at this picture showing this marble statue and how over time acid rain had worn it down. So it was a chemical reaction between the limestone rock and the acidic material in the air caused by sulfuric acid and nitric acid from emissions of air pollution from different factories mixing with the water in the air. And so that caused the rain to be more acidic. Limestone caverns, lots of different types of caves have these formations, and these solution caves are basically formed by the carbon dioxide in the air mixing with water as it infiltrates down into the soil, as the rain is soaking down into the soil, and that forms carbonic acid, which eats away at the limestone material. Number 8, this is fill in the blank. The crust and upper mantle together are known as the lithosphere. Remember, your stem litho refers to rocks. This layer of earth is broken into sections that's called plates, and generally it's specifically called tectonic plates. Number 9, what's the difference between an earthquake focus and the epicenter? So the focus is going to be the place where the energy is released underground, and the epicenter, epi refers to on, your stem, epi means on, so it's on the center, it's on top of the focus, except for the epicenter is going to be directly above the focus, and it's going to be on the ground. A little comparison real quick of P and S waves. P waves are primary waves. They're going to be the fastest waves that are generated in an earthquake, and they're compressional, so it's kind of like a slinky. If you've ever played with one of those little kids' toys, you can see how it's traveling in this longitudinal motion. So it's going sideways. The particles are moving sideways. P waves also can travel through solid and liquid. So P waves can be registered at different parts throughout the world. S waves are secondary waves. They're slower, and they're the ones that are going to cause lots of damage and what you feel in an earthquake. S waves are only going to travel through solids, so they may not be registered at different places across the world. They're going to be registered more locally, and you can see how it's moving up and down, and so that's why it causes so much damage. Number 10, what's the difference between magma and lava? Magma is underground in magma chamber, and lava is when it has reached Earth's surface and when it's released from a volcano or at a hot spot or something like that. So both magma and lava refer to hot rock that is so hot that it has melted into the liquid. Number 11 is referring to the different plate boundaries. Again, we've talked about this in science class. Con means together. Di refers to two, as in two separate directions. So convergent plates move together, divergent move apart, transform, slide past one another. When you have convergent plate boundaries, if it's ocean plates, the one that's more dense is going to be subducted. It's going to move under the other one. Volcanic arcs, volcanic island arcs can also form at these points. Continental ocean convergent boundaries, the more dense ocean plate is going to subduct, and this can form trenches as the plates are moving together. Volcanoes also can form, and at continental convergent boundaries, as the continental plates smash together, they're going to move upward, forming mountains. At divergent plate boundaries, so oceanic divergent plate boundaries is going to be like at the mid-ocean ridge for seafloor spreading to occur. So new ocean crust is going to form, new ocean floor. Continental divergent plates, you can have rift valleys that form. So basically the continents are the land mass itself is pulling apart, and a lot of times those fill up with water. And then transform plate boundaries are just going to slide horizontally past one another, and it's not going to be destroying material. It's not causing subduction to occur. They're just sliding past one another, and the San Andreas Fault is an example of that. So which structure can form as a result of a divergent plate boundary? So we just talked about that, and we have divergent plate boundaries. The plate boundaries are pulling apart. The biggest example of divergent plate boundary is mid-ocean ridge, seafloor spreading, new ocean floor being formed. So your answer, mid-ocean ridge. Which will most likely occur before a volcanic eruption. So before a volcano erupts, you're going to have an increase in earthquake activity because there's a lot of tectonic activity, a lot of geologic activity that's going on. And just remember that the ring of fire is basically the localities for a lot of different earthquakes and volcanoes worldwide, mapped out on a globe, end up basically forming the ring of fire like a big chain around the Pacific Ocean. So that kind of illustrates that volcanoes and earthquakes go hand in hand a lot of times, which is most likely going to form when a plate boundary forces land mass to be pulled apart. So this is referring to continental divergence. Land mass pulled apart. So this is not using the exact scientific terms for it. It's putting it into kind of definition terms. So when continents pull apart, you're going to have continental rift. Number 12, what's sustainability and conservation? So conservation is just saving. It's using a resource wisely so you're not wasting it. And sustainability is going to be using a resource but also replenishing it so that you have more in the future. So if you're cutting down trees to use for biomass, then you're replanting trees. So it's replenishing that resource so that it's not all consumed. Number 13, what are fossil fuels? So again, we've talked about this a lot. Oil, natural gas, and coal are your examples of fossil fuels. Fossil fuels, use a key term there, fossil. They're made from remains of dead plants and animals. They take millions of years to form, which is why they are considered to be non-renewable resources, because they take so long to form, so they are used quicker than they are able to be replaced. And one question is, are they biotic or abiotic? So they used to be alive, right? But that was millions of years ago. So it's abiotic. The substance is a geologic material. It's extracted as rock or ore. Number 14, how does mining, harvesting, drilling, hydrofracking impact the environment? Basically in bad ways. So mining, you're going to be obtaining uranium or coal. To obtain coal, you might use surface mining like strip mining. So that can cause sinkholes, it can cause loss of biodiversity in habitats, and it can also cause pollution, particularly of groundwater. Harvesting, so if you're harvesting wood or lumber, like for biomass, that can cause lots of damage to ecosystems and habitats, also reducing biodiversity. And it needs to be sustainable harvesting. You should be replenishing the resource as you're using it. Drilling for oil. We all know there can be oil spills, and then dispersant that is applied to oil spills, like in the Gulf with the different oil spills that you may have heard of in the past, like 2013. The dispersant that is applied to help kind of absorb some of that oil is harmful to ecosystems. It's harmful to corals and different types of animals in the ocean too. Hydrofracking is also called hydraulic fracturing. No matter which way you see that on the EOG, it has hydro in it, right? So that refers to water. So it's going to be abstracting hydrocarbons, specifically natural gas, and that can cause a loss of habitat. It also, one of the biggest factors is that it can cause contamination of groundwater. How can oil and natural gas be extracted from the earth? So a lot of things are going to be mined or drilled from the earth. Oil, you're going to be drilling for that. Natural gas, you're going to be drilling for that, or using hydraulic fracturing. So drilling deep beneath the ground is going to be your answer. So no matter which one you're extracting, if you're doing hydrofracking or if you're drilling for the oil, it's going to be deep beneath our surface. Strip mining also is the one that was used specifically for extracting coal primarily, which is an advantage of safely using uranium as an energy source rather than using coal. So we know both of those are non-renewable sources. Coal is a fossil fuel. Uranium is going to be using or generating nuclear energy. So uranium is going to be splitting apart atoms. So it's going to be nuclear fission. So which is an advantage. You're looking for something good that can be a result. So we know that coal, since it's a fossil fuel, is going to lead to global warming. It's going to generate a lot of carbon dioxide. So that's probably what we're going to be looking at in the answer. So your answer is uranium produces energy without polluting the atmosphere, while burning coal can increase the carbon dioxide in the atmosphere. So this one is looking for an advantage of uranium over coal. If this had been looking at a disadvantage of using uranium for energy, of course, radioactivity and nuclear meltdowns would be disadvantages. This is a little image showing you hydrofracking or hydraulic fracturing, just so you can kind of see this process taking place. So water, slick water, is what's referred to as basically a mixture of water, sand, and chemicals. It's going to be pumped down into the ground and pumped laterally so that it's going to cause these fractures in the ground so that natural gas can escape. So the big risk here is contamination of groundwater. And we know groundwater is used as the main drinking source, the main source of usable water. Number 15, list 5 different types of alternate energy sources and give an advantage and disadvantage for each of them. So this image is showing your different alternative renewable energy sources. We have geothermal, hydroelectric, biomass, solar, and wind. So wind, first one. Advantage, it's not going to be producing pollution. It's infinite. It's also expensive, so that's a downfall. Some people refer to it as visual pollution because they're not pretty, but they're effective, and they can't be used in all places. So certain places don't get enough wind to have wind turbines, and they can also kill birds and bats, so things that fly, so that's bad for living organisms. Advantage of water, of hydropower, it's not going to be producing pollution, and again, potentially infinite. A disadvantage is that it can harm ecosystems and can cause flooding. A local government's considering whether to build a dam, which is an advantage of building the structure. So an advantage to building the dam is that it's going to be able to create a reservoir. It'll basically create a storage place for lots of water. Solar, the third one. Advantage, no pollution is going to be produced, potentially infinite. A disadvantage is the photovoltaic cells, the solar panels are expensive to set up initially, and it's going to use a lot of land that could be used for other things like farming. Biomass. An advantage of biomass is it's not going to produce a lot of pollution. It's potentially infinite. It does need to be sustainable. So if you're using wood or corn crops for to generate energy and you're not replanting them, then it's not going to be sustainable. And then geothermal. It's only available in certain areas where you have volcanic activity and you have magma chamber, but an advantage is it's not going to produce pollution and it is potentially infinite. And that's all for this part. So you should have down through the energy sources complete.